Okay, the first problem on the quiz is going to be a factoring problem involving a difference of cubes. Could be a sum of cubes. Keep in mind if it's a binomial and we have powers that are cubic, meaning that they divide by 3, or cubic numbers such as 1, 8, 27, 64, to some number to the third power. If they have a plus or a minus, they're going to be factorable as a binomial. And always the first step of factoring is greatest common factor, which obviously this doesn't have one. So the main idea is if we're considering this as a difference of cubes, we should be able to write down both objects as something raised to a third power, which we can see this is like that. Once you recognize it as a difference of cubes, it's just a matter of taking the cube root and the sign in the first parentheses. And the cube roots are simply what would be in the cube. So if this was x to the 9th power, 9 divided by 3 is 3. If it was 125, 5 times 5 times 5 is 125, so you get whatever you get. The second parentheses is created by making 3 pieces. Piece 1 is the first object squared. Piece 2 is the product of the two objects, whatever they are. In this case, 3 and x just makes 3x. And piece 3 is the second object squared. And as far as the signs are concerned, it's always the same sign in the first parentheses. The very next sign is always the opposite sign. The last sign is always plus. And that would be the entire thing. So your factored form for that one would be this. Problem 2, this time we have a 4-term polynomial. We're looking at factoring by grouping as the likely way to do this. Once again, looking for common factors before we start. There's an x, 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 and no x, and there's a z, 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 but no z, a couple w's. So there's no common factor to everything, so again we go directly to the factor by grouping when you have 4 terms. So the groups will be the first 2 objects, and the third term is positive, so there's a plus sign here before the second parentheses. Always start with the grouping of the first two and the last two. And again, whatever sign's in the middle goes in the middle, but if that were a minus, this second object here would change sign. Once you've done that, you're looking for a common factor in both groups. The first group, x is in both. We can take the lowest power out, so 2, 1, we take the 1. Same with z, the lowest power is 3. And once we take x z cubed out, what's left in the first term? If I take x z cubed out of that, it's just be x to the first. If I take x z cubed out of this, x goes away, z cubed is going to drop z to the 4th down to z. It is a minus, it stays minus. In the second group, we have a w in both terms, so I take a w out. If I take a w out of both terms, what's left from this will be x, what's left from this will be minus z. And when factor by grouping works properly, the binomial that's left here and here should be exactly the same. You should expect that to happen on the actual quiz. So once you see that those are the same, the common binomial, whatever it is one of the factors, and the greatest common factors we took out, including this sign, whatever that sign is the other factor. Notice they are being multiplied together. There's no plus sign in between. It's the first factor times the second factor. First factor is the common binomial. The second factor is whatever the common factors were. And that's it. Number 3, one more factoring problem. This time it is a binomial. This time we're looking at an even power, which makes it a perfect square. We're also looking at 16, which is 4 squared, 81, which is 9 squared. And it is a difference. And with the sum of difference of cubes, it could be a sum or a difference. For squares, it has to be a difference of squares. So what we're looking at here, again, if I can see that they're perfect squares, and keep in mind, whatever the power is, half of that power is what's being squared. So x to the 4th squared is the same as x to the 8th. So what we have here for difference of squares is 4x to the 4th plus 9 and 4x to the 4th minus 9. Now the directions do say factor completely, and what you should notice, if you're paying close attention, is that this is a sum of squares, 4 is a perfect square, x to the fourth is x squared squared, 9 is 3 squared, but they're being added together, so factoring that's not possible. Where here, 2 times 2, x squared times x squared, 3 times 3 being subtracted. This is another difference of squares right here, so that factors again. So I'm going to keep 4x to the fourth plus 9 as is, and I'm going to take the second factor here, and I'm going to factor that as a difference of squares. 2x squared times 2x squared, 3 times 3, 1 sum, 1 difference. And finally, if you look at this last one over here, we still have a binomial. X is still being squared, it's still being subtracted, so that difference of squares is still possible on that one, but 2 and 3 aren't perfect squares, so I can't go any further using integers as coefficients. This is added, so it's irrelevant, also added irrelevant. The only way you have to worry about adding with binomials is with cubes. Fourth power and second power aren't cubes, so we don't have to do anything else there. So the best complete answer would be this right here. If you get on the quiz and stop here, you'll lose probably 3 or 4 points out of 10. You have to go all the way to the end in order to get full credit. Problem 4. This is an absolute value equation. We dealt with these specifically in class, and what I told you was once the absolute value expression is by itself equal to a positive number, you're supposed to transform this into 2 separate equations. You take whatever's inside the absolute value bars, set it equal to whatever that number is, put the word or, and then take whatever's inside the absolute value bars and set it equal to the opposite of that number. You do have to get 2 answers to get this completely right. On homework, I know some of you only got 1 answer, so be careful that you get 2 answers on this. But again, the absolute value bars disappear when you separate this into 2 separate equations. The guts of the absolute value equals the number and the opposite of the number to make the 2 equations. The 2 equations you make are simple algebra equations, 2-steppers. Move the 6 over first, divide by 2. Move the 6 over first, divide by 2. And both of those answers, 2 and -8, would make the original equation true. So both answers are valid. You could use brackets or set braces like this to identify a set of answers. If you did want to check these just real quick to be sure, I put x equals 2 and I'm going to have 4 plus 6 is 10, make it positive, it's 10. I put -8 and I get -16 plus 6 is -10. Absolute value bars make it positive, so it changes to positive 10. Both answers work, both answers are valid. Number 5 asks us to solve a quadratic equation, and 72x squared plus 13x equals 15. The first step is to get it equal to 0. Now you might try to factor it. In my opinion, that would be pretty tough to factor, so I'd probably go directly to the quadratic formula. The numbers here are rather large, but the quadratic formula should work as it normally does. And keep in mind, when we use the quadratic formula, we're always finding the value of this variable, in this case x, so that's what we're finding as an answer. It should be quadratic on the equation instead of quadratic in form. And also, I usually just go ahead and write the structure of my answer, knowing I have to fill in these 3 locations with what they are. What goes here is minus b. b is positive 13, so minus b is negative 13. What goes right here is 2 times a. a is 72, twice that is 144. And what goes here is b squared minus 4ac. That's a little bit more involved, so b squared minus 4ac will be 13 squared, which is 169. b squared is always positive. Minus 4 times a, which is 72, times c, which is negative 15. That's not easily evaluated, so I would probably come over here. 4 times 72 times 15 comes out to 4,320. And the 2 minuses make a plus. So I had 4,320 to 169, I get 4,489. Okay, that'd be priority 1 for me, is to get the answers. And I say answers because it says plus or minus, that's 2 answers. Once I've established the value of the three pieces of the quadratic formula, my next job is to see if it simplifies it all. And that just really boils down to this 4,489 if it has a nice square root. So I try square root of 4,489, it comes out to 67. That's not good. There we go. So square root of 4,489 is 67. So I end up with x equals negative 13 plus 67, which is 54 over 144. And negative 13 minus 67 is negative 80 over 144. Then what's left to do is to reduce, if possible. 144 and 54 divided by 9. And then 6/16 reduces down to 3/8. And 80 1/44 reduces by 4 at least, down to negative 20 over 36. That reduces by 4 again, down to negative 5/9. So that'd be your two answers. I don't know if the numbers will be quite that large on the quiz or not, but if they are, I mean, they're within everybody's capability of evaluating. Just be careful, again, this minus makes a plus happens very often, so be watching for that. Make sure equals 0 occurs in your equation before you apply the quadratic formula. Chances are it'll come out to a pretty friendly answer like this. I would expect it to be a radical that simplifies, so if it doesn't, chances are you messed up somewhere in the calculations over here more than likely. Number 6, rational equation, 6 over 8 plus x equals 4 over 8 minus x. If it happens to look exactly like this, cross multiplying is legal to fix this. Before we cross multiply though, we should consider the denominators of 8 plus x and 8 minus x. Anytime x is in the denominator of a fraction in an equation, we have to assume that there are values of x that can create zeros. In this case, those values would be positive and negative 8. If x equals negative 8, 8 plus negative 8 is 0. If x is positive 8, 8 minus positive 8 is 0. Division by 0 is undefined and not allowed, so we'd have to put those numbers over there to assume that, or to assure that we don't actually allow those to be answers should they show up as answers. Once again, cross multiplying will work effectively on this. If there was a third term, like it says plus 3 or something, multiplying by 8 plus x times 8 minus x would work. I'm going to go ahead and use cross multiplying. So this product, 6 times 8 minus x equals this product, 4 times 8 plus x. Distributive property is 48 minus 6x. Distributive property here gives me 32 plus 4x. I would probably move the 6x to the right, the 32 to the left. So plus 6x goes over here, minus 32 goes over here. 48 minus 32 is 16. 4x and 6x makes 10x. Dividing both sides by 10 gets me x equals 8/5. 8/5 is neither 8 nor negative 8, so that's a fine answer. There's nothing wrong with it. I would prefer a fraction to a decimal. If it ends up being that way, if it comes out whole, that's fine, or integer, that's fine, but it could come out to a fraction. I'm not going to try and make it come out nice and pretty necessarily. If one of these answers happened to show up, and that was the only answer, let's say we got x equals 8, you'd have to throw it out, put an empty set. It may or may not happen. They're kind of tough to make, so I'd say more likely it's not going to happen, but just be watching for that possibility. Number 7, we have a radical equation. Both radicals look equally ugly, so I would probably keep it the way it is. Currently, the way it's written, 2x minus 5 inside the square root is isolated on the right-hand side, where 2x plus 11 inside the square root of 2 minus 2 is on the left-hand side as a binomial. So in order to get rid of a radical, we're going to square both sides to get rid of this radical on this side, the one that's isolated. So I'm going to square this side to get rid of the radical. The consequence is I have to square this side. On the right-hand side, squaring a radical just gets rid of the radical, so it makes it pretty straightforward, easy to do. On the left-hand side, we have a binomial raised to that power. So here's first term, here's second term. And the shortcut for squaring a binomial, as we learned earlier this year and also last year, is we square the first object. So just like the square root of 2x minus 5 squared was just 2x minus 5, the square root of 2x plus 11 squared is just going to be 2x plus 11. That right there represents the first object squared. The second piece of the shortcut is we multiply these together and double the product. So 2 times negative 2 times the square root of 2x minus 11 makes negative 4 times the square root of 2x plus 11. And then the third piece of our trinomial that is made by squaring a binomial is we take the second piece, we square it, and the squares are always positive. So this one squared was positive, this one squared was positive. When you square this, if there's any signs in between, like that said 2x minus 11 stayed minus, but positive just means the signs stay as they should. So these are both positive, they stay positive. Even though that's negative, it becomes positive because you're multiplying by itself. The only time a negative would show up is in the product of the two, so opposite signs get a negative. And again, double it. 2 times 2 is 4 outside, the square root of 2x plus 11. Now once I've done all this, squaring both sides there got rid of one of the two radicals in the expression. So the next thing I have to do is get rid of the second radical. So the next thing I want to do is I want to move everything to one side. I personally like my radical term to be positive, so I'd probably move this 4 times the square root of 2x minus 11, which is negative, over to the right-hand side, and slide the 2x and the 5 over to the left-hand side. So I'm going to get a minus 2x and a plus 5. I lined up like terms. There's like a like term here and here, so take your pick. All right. So both of these guys moved, and this guy's moving over there. So if I combine all my like terms over here, 2x minus 2x happens to cancel. 11 plus 5 plus 4 is 20. And I'm moving the green over to the other side, becomes positive 4 times the square root of 2x plus 11. And then the next thing I do, if there's a number in front, I see if I can divide it evenly. If I can, I should. If I can't, I would probably just leave it as is. In this case, I can divide evenly. Divide both sides by 4, you're left with 5 on the left, and the 4 goes away on the right. Once again, I'm at a point here where the square root equals a number, just like I was here. Square root equals stuff, square root equals stuff. So I'm going to square the right-hand side to get rid of the radical. The consequence is I square the left-hand side. And that gets me to 25 on the right, on the left, is equal to 2x plus 11 on the right. And then what's left to do is to solve for x. Minus 11 gets me 2x equals 14. So therefore x would have to equal 7. The final step of a radical equation is we need to verify that it actually works in the original problem. So we go back to the problem as it was written initially. We change both the x's into 7s and work it out to see if it actually makes a true statement. I'm actually going to mentally do some math here. So I'm putting 7 in place of x. 7 times 2 is 14 plus 11 is 25 for that radical. Minus 2, which is just minus 2, equals the square root of, if I put 7 here, I'm going to get 14 minus 5 is 9. That gets me 5 minus 2 equals 3, which obviously is true, which means x equals 7 is a fine answer, and it will be encircled. If all this happened, and let's say it said negative 5 minus 2 equals 3 or something weird like that, it's untrue, then you would strike that out, put the empty set, say there's no answer. Chances are it'll have a workable answer on the test. So I would expect not to get an empty set answer for that, but just know that's how to handle it if it should occur. Number 8, very much like the other quadratic equation, this time it's quadratic in form. So x to the 4th minus 20x squared plus 64 equals 0. We can see that we have a power of x. We have half as big a power of x. It is a trinomial followed by a constant equal to 0. So the quadratic formula is legal on this one. The only thing we have in addition to the quadratic formula, though, is instead of getting x equals, we're going to get x squared equals. And what I'm looking at in the original problem, a is equal to positive 1, b is equal to negative 20, and c is equal to 64. And if I go ahead and do my 3 pieces of the quadratic formula again, what goes in this location is minus b. B is negative 20, minus b is going to be positive 20. What goes on the bottom is 2a. A is equal to 1, 2a will be 2. What goes in the radical is b squared minus 4ac. And I typically work that out. B squared is going to be 400. Again, even though B is negative this time, B squared it gets positive. Minus 4 times A times C. 4 times 64 is 256. This time the signs are all the same in here, so minus stays minus. And 400 minus 256 is 144. So once again, we're doing the quadratic formula. We do all the stuff like normal, but instead of getting x equals, we're getting x squared equals, because that's the second term in this trinomial. And that means x squared is equal to 20 plus or minus 12 over 2, which means x squared is equal to either 32 over 2 or 8 over 2. 20 plus 12 is 32 on top over the bottom of 2. 20 minus 12 is 8 on top over the bottom of 2, which leaves me with x squared is equal to either 16 or x squared is equal to 4. And since x squared equals 16, that means either x is positive or negative 4, and if x squared is equal to 4, x is either positive or negative 2. Do be careful if you do a quadratic form with an x squared or even an even power here. When you take the root, in this case the square root, you have to take the positive or negative square root. If it's an odd power, you can just take one root, and the sign will be whatever the sign is. So if it's x cubed equals a positive number, you get one positive answer. If it's x cubed equals a negative number, you get x equals one negative answer. If they aren't as friendly on the actual quiz, then give me decimal approximations or leave it in radical form. Simplify as much as possible. Number 9, this is a quadratic inequality. First step of quadratic inequality is get the quadratic expression on one side, inequality symbol followed by 0. So x squared minus 3x minus 28 is greater than or equal to 0. Next task is to factor as much as is possible. If possible, if not, quadratic formula will be sufficient. You're trying to find the roots of the expression. So you're trying to find out where this thing equals 0. In this case, it does factor to x minus 7 times x plus 4. And we're staying with greater than or equal to 0. All right. Negative 7 times 4 is negative 28. Negative 7 plus 4 is negative 3. That means when x equals 7 or negative 4, this expression equals 0. So we've got the equals 0 part taken care of. Now, what I do with these two answers is I create intervals. And those two answers are two stopping points along the way where the sign of this expression can change from positive to negative. I don't know what it is at any point in time at this juncture, but I can at least set up intervals to establish that for a specific location, the sign will be whatever it is and it won't change. So all the way from negative infinity to the smallest number in my list of answers here, it's going to be one sign. I don't know what that sign is yet. And I'm going to put a bracket at negative 4 because of the equals to. If it was just greater than, I would put a parentheses. I always put a parentheses at the infinities. The next bracket at negative 4 goes to 7, also bracketed, because again, equals 0 at 7. 7's an answer, so we want to include that answer in our solution. And then finally, I'm going to go from 7 bracketed to infinity parentheses to show again that there's no definite ending point, but it goes forever to the right. This goes forever to the left. Negative 4 is equal to 0. Negative 4 and 7 are both equal to 0. 7 is equal to 0, so the brackets distinguish that we're including that as part of our solution. All that's left to do is to test each interval to find out what sign it is. So again, this is some sign all the way through, either always positive, always negative. I don't know what it is yet, so I pick a test point to establish that. So negative 5 is between these two numbers, 0 is between these two numbers, and 8 is between those two numbers. And I'm not going to go back to here, but instead to here. I've got a product, and if I substitute negative 5 in place of x, negative 5 minus 7 is negative 12. The negative is what matters. Negative 5 plus 4 is negative 1. The negative is what matters. Two negatives multiplied make a positive, so this interval here is going to be a positive interval. So any number I pick on that interval, the outcome will be positive. If I put 0 in, same deal. Parentheses, parentheses to represent this product. 0 minus 7 is negative 7. 0 plus 4 is positive 4. Again, the signs are what matters. If I multiply a negative times a positive, I get a negative. For that entire interval, the outcome of this expression is going to be a negative number. And finally, for this last one, my test point is 8. I'm trying to evaluate both of these at 8 to see what kind of signs I get. 8 minus 7 is positive 1. 8 plus 4 is positive 12. Again, the signs matter, the numbers don't. Two positives make a positive when I multiply. The inequality we're looking at says greater than or equal to 0, so positive is what that means. So positives is what we're looking for. So this one's positive, this one isn't. So we throw that one out. And so the solution will be negative infinity to negative 4 bracket union with 7 comma infinity. Bracket on the 7, parentheses on the infinity. It only says solve, so I'm going to stop there. If you feel like graphing it, you can, but I'm going to be looking for a solution looking like that. When you get multiple answers, make sure there's a union symbol there between the two intervals that work. If it's only a single answer, just write the single answer, but multiple answers, make sure you do interval union with another interval, like so. And finally, number 10, we have a rational inequality. And again, just like the last one, it has to be less than 0, not less than 2. So before I start actually working this out, I would move the 2 to the other side to get a less than 0. And 2 is currently over 1. I need it to be over x minus 5. So I have to put an x minus 5 on top and bottom to allow myself to do that. When I go to simplify the top, this expression here is negative 2 times that stuff, so I actually get negative 2x plus 10 out of this. X minus 2x makes negative x. 2 plus 10 makes plus 12. So negative x plus 12 over x minus 5 is less than 0 is the inequality we're looking at now. Signs can change if the top or bottom equals 0 in a rational inequality, so we have to establish when the top and or bottom equals 0. If they don't equal 0, they don't count. If they can equal 0, those numbers count. So looking at the top, I simply take what the top says, set it equal to 0 and solve. Move the x over there, I get 12 equals x. So if x equals 12, negative 12 plus 12 is 0. The top equals 0 there. For the bottom, same deal. We set the bottom equal to 0. If I move the 5 over there, I'm going to get x equals 5. So if x is 5, 5 minus 5 is 0, the bottom equals 0. A sign can change. All right. Now, if this said less than or equal to, I would bracket top zeros. I would only put parentheses on bottom zeros because I can't divide by 0. Since it's just less than, everything's in parentheses. So the smallest number on my list here is 5. My biggest number is 12. Again, I start from negative infinity, go to infinity, hit every stopping point along the way to make my interval. So negative infinity to 5 is interval 1. 5 to 12 is interval 2. 12 to infinity is interval 3. And again, everything's parentheses because it says less than. If it said equals to, the top 0 is 12, so these guys would be bracketed. These would still be parentheses because we couldn't allow the expression equals 0 when x is 5 because it actually is undefined at that value. Okay, but again, ours does not have less than or equal to, it just has less than, so we're going to go with these intervals the way they are. My test points, again, something between negative infinity and 5, I would pick 0. Between 5 and 12, let's go with 6. Between 12 and infinity, 13. And again, all I'm doing is determining what this value is at each of these numbers. So I just make a fraction bar. 0 or negative 0 plus 12 is positive. 0 minus 5 is negative. Positive divided by negative gives me a negative result. Put 6 in. Negative 6 plus 12 is positive on top. 6 minus 5 is positive on bottom. Positive over positive gives me a positive result. If I put 13 in, negative 13 plus 12 is negative 1 on top. 13 minus 5 is positive 8 on the bottom. Negative over positive is a negative. This does say less than 0. Less than 0 means negative. So negative answers are what we're looking for. This is negative. This is negative. This is not. So we throw that out. Once again, we get multiple answers. So I'm going to put negative infinity, comma 5, union with 12, comma infinity. What I typically do on partial credit is if you get a bracket where there's supposed to be parentheses or vice versa, then I'm going to deduct a point per answer. So let's say this is supposed to be bracketed and that too, that'd be 2 points. You know, if you put brackets where parentheses belong, or going back here, if you put parentheses, that'd be 2 points off. If you got one of them right, the other one wrong, then just 1 point off like that. If you get the answers wrong, I deduct more points. Typically I'm looking at how you work them out. how you work this out, and then looking to see that you did proper steps. You got everything less than 0, you added things in correctly, you found the right zeros, you made the right intervals, you tested with good points. That kind of stuff is what I'm looking for to count for partial credit on that problem. That's what the test looks like, or the quiz looks like, I should say. If that did not help you enough, come see me at your time, and hopefully we can get this done well.